In the area of science and gigantic mysteries, the subject of what existed previously to the gigantic explosion has blended conversations and intrigued characters for quite a while. This huge question doesn't just test how we could decipher the universe, it challenges the genuine furthest limits of human knowledge. Imagine standing at the edge of existence, looking into the colossal unknown, observing and pondering the contents that existed before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. Anyway, was there a second earlier, previously this? Could there have been a condition of nothingness, a calm before the cosmic gathering started? And if this is true, was it? Or perhaps there was something much more alarming that existed previously, before time itself? As we jump further into this question, science takes us on a journey past the insight into the beginning of the universe, one that challenges our consciousness. Physicist Brian Cox, known for his investigation into the wonder of the universe, suggests that something surprising might have existed before the enormous detonation. He moves us to reconsider our thoughts on reality and existence. In this examination, we'll dissect the theories, the research, and the dazzling insider secrets that might make sense of what existed preceding all that. We'll explore thoughts like self-important development, quantum changes, dark energy, and even multiverse. The answers we've revealed might just paralyze you, yet they could likewise open new understandings of our position in the universe. Get ready to jump deep into a world beyond imagination and science, where the obscure still wins around the shadows, leaving scientists flawed and sometimes even upset. We ought to explore what existed before the Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we first need to painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely hot and dense, growing rapidly to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning, with galaxies spreading out in all directions from an early stage point. However, for what reason did this happen? Furthermore, was there a period before this thick, hot start? As indicated by the theory of enormous expansion, there was, without a doubt, a before, and it was not even close to void or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Anyway, this vacuum wasn't entirely empty. It contained a gigantic amount of energy that fueled the quick extension of space itself. This extension, called inflation, happened so rapidly that it basically established the groundwork for all that would continue in a fraction of a second, space extending at unfathomable rates until the extension slowed down, and the energy changed into matter, particles, and the forces we see as the Big Bang. But what was the nature of this energy? For what reason did it suddenly grow the universe? And why did it stop? Specialists believe that this inestimable expansion made patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly with minuscule air pockets forming here and there, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our understanding of the very universe itself and leaves us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real. At any rate, as per our current understanding, regardless of whether you eliminate all energy, particles, and radiation from the universe, it would still not be genuinely void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable embroidered tapestry of something, even in its most vacant structure. Regardless of whether we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has constants, rules, and properties that prevent it from being totally empty. Imagine creating a region with literally nothing in it, no particles, no radiation, and no energy. Except quantum fields and major constants, these would still exist, suggesting that this nothingness has properties. For instance, there's a peculiarity called zero-point energy, which represents the least possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a spooky resonance of movement, even in what should be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, there was a phenomenon that only scientists are beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe while inflation continues in different areas, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept of a fractal universe, where each new universe might actually make its own Big Bang. Every universe exists as a separate, independent domain, unaffected by the others because of the rapid expansion of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe being just one bit in a giant cosmic structure, forever expanding and constantly making new universes. And what if the disturbing reality is that there is no before or after, but rather a timeless pattern of universes forming and decaying? How we may interpret nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that connect everything in the universe to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields momentarily, acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. Could the universe have emerged from quantum fluctuations? One of the most compelling theories suggests that the universe may have originated from quantum fluctuations in a pre-existing quantum vacuum. Quantum mechanics teaches us that even in a vacuum, where no matter or radiation exists, there are still fluctuations due to the uncertainty principle. These fluctuations cause tiny energy imbalances that can momentarily create virtual particles. In rare cases, some fluctuations might become stable enough to expand and evolve into an entire universe. This idea, known as quantum tunneling, suggests that the universe could have popped into existence from a pre-existing quantum state, essentially from nothing, but not truly nothing. If this theory holds, it means that before our Big Bang, there was a timeless quantum landscape, where universes constantly formed and dissolved like bubbles in a vast quantum ocean. Our universe might just be one of many, shaped by the rules of quantum physics, emerging from an endless cycle of fluctuations. The cyclic universe. Was there another universe before ours? Another mind-bending possibility is that the universe didn't truly begin with the Big Bang, but instead, it is part of an eternal cycle of expansions and contractions. This idea, known as the cyclic model, proposes that the universe goes through endless phases, expanding, cooling, and eventually collapsing in a big crunch, only to be reborn again in a new Big Bang. If true, this suggests that before our universe, there was another one, possibly similar to ours, that eventually collapsed and led to the formation of what we now experience as reality. This theory eliminates the need for a singular beginning and instead replaces it with an eternal rhythm of cosmic rebirth. Some versions of this theory propose that each cycle might alter the fundamental laws of physics slightly, meaning every new universe could be different from the last. In one cycle, the speed of light might be different, or the laws governing gravity might change. Could it be that an infinite number of past universes have existed, each with its own unique physics? The role of dark energy in a pre-Big Bang cosmos. Another mystery that might hold clues about the pre-Big Bang universe is dark energy, the mysterious force causing the accelerated expansion of our universe today. Some theories suggest that dark energy could have existed before the Big Bang, influencing the conditions that led to the birth of our cosmos. Dark energy is currently driving galaxies apart, making space expand at an ever-increasing rate. But what if, before the Big Bang, a different form of dark energy existed, influencing the quantum state of the universe? Could it have played a role in triggering inflation and shaping the structure of spacetime? Some researchers propose that dark energy might not just be a property of our universe but a fundamental force that has existed eternally, shaping countless universes in a multiversal framework. Could our universe be a hologram? A truly radical idea is the holographic principle, which suggests that the universe as we know it might not be a three-dimensional reality but rather a projection of information encoded on a distant cosmic boundary. If this is true, It raises an astonishing question. Was there ever a true beginning, or is what we perceive as the Big Bang just a shift in the way information is processed in the universe? Some physicists believe that what we call the Big Bang might simply be a phase transition, like water turning to ice, rather than an absolute beginning. In this view, the universe could be an ever-existing, shifting structure of information, constantly evolving through different states rather than having a single point of origin. The search for evidence. While these ideas are fascinating, they remain speculative. However, scientists are actively searching for clues about what may have existed before the Big Bang. Cosmic microwave background, CMB, radiation. Some researchers believe that imprints from a previous universe could still be visible in the faint radiation left over from the Big Bang. Patterns in the CMB might reveal evidence of past cosmic cycles or interactions between universes. Primordial gravitational waves. If inflation occurred before the Big Bang, it might have left behind gravitational waves, ripples in spacetime that could provide insights into pre-Big Bang physics. Quantum experiments. Scientists are attempting to recreate early universe conditions in particle accelerators, searching for exotic particles or behaviors that might hint at what existed before our cosmos. The endless cosmic mystery. At its core, the question of what existed before the Big Bang challenges our deepest assumptions about time, space, and reality itself. Whether the answer lies in quantum fluctuations, eternal cycles, or multiversal landscapes, one thing is certain: the more we learn, the more mysterious the universe becomes. Perhaps we are only scratching the surface of a far greater cosmic truth, one that stretches beyond human comprehension. And perhaps, just as ancient civilizations once looked at the night sky and wondered what lay beyond, we too are only beginning to grasp the infinite wonders of existence. Detected could reveal new understandings of the universe's earliest times. These waves might be of use as the echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of gravitational waves in their early stages is one of the most exciting possibilities in cosmology today, as it might not only reveal the truth about the Big Bang but also offer a glimpse into the cosmic state prior to the birth of our universe. Theory presents a tempting possibility: detecting gravitational waves that could act as traces of an earlier Big Bang universe. As we continue to explore what could have existed before the Big Bang, we delve into concepts that push the boundaries of our understanding, challenging even our most fundamental presumptions regarding space, time, and existence itself. One of the most mind-boggling ideas comes from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger could potentially reveal a unified theory of everything and might offer insight into what existed before the Big Bang. Quantum gravity suggests that space and time are not smooth, continuous entities as we experience them but instead are discrete, granular structures. This theory posits that the fabric of spacetime itself could have been formed from a microscopic Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time might have only emerged from these changing quantum fields, resulting in a radically different concept of reality before the Big Bang, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each emerging from its own distinct Big Bang. This landscape also suggests the idea that other universes might have different dimensions, different strengths of gravity, or even different types of matter. In this view, our universe might not be unique but rather part of a multiverse, a collection of universes, each independently developing. The multiverse theory provides a speculative yet fascinating answer to the question of the universe prior to the Big Bang, another universe in a different configuration, potentially leading to infinite cycles of creation and destruction with no definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. A hypothesis gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the creation of new universes, suggesting that what we consider the Big Bang was just the birth of our universe from the singularity of an ancient black hole. Exploring these concepts necessitates a thorough investigation of the very nature of time itself. Some cosmologists speculate that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. According to this view, time itself might have emerged from a quantum fluctuation or from an initial state in which the common differences between the past, present, and future did not apply. This could lead us to rethink the concept of causality, which relies on the assumption that events happen in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes nonsensical, as there would be no temporal structure to support the inquiry. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology suggests that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the most recent bounce in an eternal series of universe cycles. These cycles might not be identical but could change in different ways, each with unique physical properties. The cycle of the universe, according to this theory, would be a continual process with no true beginning or end, rendering the question of before the Big Bang meaningless in the conventional sense. The idea that time itself might be cyclical suggests that every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of investigation into the nature of the cosmos is the potential of a primordial soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that before the rapid expansion of the universe, it was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at very high temperatures and densities, laying the groundwork for the formation of matter and energy. As the universe cooled, some versions of this theory suggest that this primordial soup existed in a quantum foam, where particles constantly emerged and vanished due to the uncertainty principle of quantum mechanics. The properties of this soup could potentially offer insights into the universe's earliest moments and, by extension, what preceded the Big Bang itself. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens, new theories will continue to emerge, offering increasingly complex, and sometimes paradoxical, explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to stretch the limits of human curiosity, driving us to explore the unknown frontiers of existence. Beyond the Big Bang, the search for origins. While modern physics provides compelling theories about the nature of the early universe, the question of what preceded the Big Bang remains elusive. If time itself began with the Big Bang, then conventional ideas of before may not apply. However, alternative theories challenge this assumption, suggesting that our universe is part of a larger, more complex cosmic framework. Quantum origins, the role of vacuum fluctuations. One of the most intriguing possibilities is that the universe emerged from a quantum fluctuation within a larger quantum vacuum. In quantum mechanics, particles constantly pop in and out of existence due to the Heisenberg uncertainty principle. Some physicists propose that a similar process could have given birth to the universe itself, a spontaneous emergence from a primordial quantum field. This idea is closely related to the concept of false vacuum decay. In some cosmological models, space itself can exist in a metastable state known as a false vacuum. If this state were to collapse, it could trigger the rapid expansion of a new universe, a process similar to cosmic inflation. In this view, our universe might be just one of many bubbles forming and expanding within a vast quantum multiverse. The eternal inflation model, a never-ending cosmos. Another possibility comes from the theory of eternal inflation. According to this model, inflation, a rapid exponential expansion of space, never completely stops. Instead, while some regions of space stop inflating and form individual universes like ours, other regions continue expanding indefinitely. This leads to the idea of a multiverse, where countless universes exist within an ever-expanding cosmic landscape. In this framework, our Big Bang might have been just a local event within a much larger inflating spacetime. Each bubble universe that forms could have its own unique physical laws, and some could even have different numbers of spatial dimensions. This challenges the idea that our universe is the only possible reality and suggests a much richer cosmic structure. Loop quantum cosmology, a universe with no beginning? Another radical idea comes from loop quantum cosmology, which attempts to unify general relativity with quantum mechanics. In this theory, space and time are composed of tiny discrete loops, rather than being continuous. This means that instead of a singularity at the Big Bang, the universe could have undergone a quantum bounce, transitioning from a prior collapsing phase into an expanding one. If this is true, then the Big Bang was not the absolute beginning but rather a transformation from a previous state of the universe. This would imply that time extends infinitely into the past, with no singular beginning, just an eternal cycle of contraction and expansion. Brain cosmology, a higher-dimensional perspective. String theory offers another possibility through the concept of brain cosmology. In this model, our universe exists as a three-dimensional membrane, or brain, floating within a higher-dimensional space. Occasionally, two brains might collide, releasing enormous amounts of energy and triggering a new Big Bang. This theory suggests that what we perceive as the Big Bang was actually the result of two brains interacting, rather than an absolute beginning of time and space. If correct, this would mean that the universe has undergone multiple cycles of collisions and expansions, each leading to the birth of a new cosmos. The limits of human understanding. As our knowledge of physics expands, new ideas about the origins of the universe will continue to emerge. However, the true nature of what came before the Big Bang may remain beyond our reach. Without direct observational evidence, these theories remain speculative, though they push the boundaries of human thought and inspire deeper questions about the fundamental nature of reality. One of the biggest challenges in answering this question is the nature of time itself. If time is a property of our universe and emerged with the Big Bang, then it may be meaningless to ask what happened before it. Alternatively, if time is a fundamental aspect of reality that exists beyond our universe, then new physics may be needed to understand its deeper structure. Conclusion: the quest for the ultimate beginning. The question of what existed before the Big Bang remains one of the greatest mysteries in cosmology. From quantum fluctuations to eternal inflation, cyclic universes, and higher-dimensional realities, scientists continue to explore new ways to understand our cosmic origins. While we may never fully uncover the answer, the pursuit itself pushes the limits of our understanding and expands our perception of reality. As our knowledge of physics advances, future discoveries may bring us closer to unraveling the ultimate mystery, the origin of everything.